Hey guys, I Explore 360 here, and in today's video, I'm going to be talking about why the Earth is not flat, right? I know many of you guys think the Earth will not be flat. We already know that, but I'm addressing the minority here that does think the Earth is flat. You guys are absolute, I don't know what you guys are thinking. The Earth is obviously not going to be flat, right? We know that it's round, and obviously you guys want to be a special group, I guess, trying to maybe get some attention or something. But I will address these arguments as far as why the Earth is not flat. Before we get into this video, guys, make sure you guys like, subscribe, and hit the bell button for more videos like. Also, make sure to share this video with someone who thinks the Earth is flat. Make sure you tell them they are wrong. Now, the first argument I will be addressing today is some flat earthers think that plane routes would be different, and they would have to go in various different ways just because the Earth is round and the curvature is different. The first thing I need to address is the Earth's surface area is 196.9 million square miles, and that is a really large surface area. To put this into perspective, a 40-minute drive is about 40 miles, right? So 196.9 million square miles. I think you can get the idea. So the largest aircraft, the Antonov An-225, is the world's largest aircraft. It has a length of 275 feet and 7 inches. So to put this into perspective, it is around 0.05 miles, which is very small. It's not even half of a mile. It is 1/20th of a mile. So addressing this argument where airplane routes would need to be different, they don't need to be that much different because an aircraft is very small compared to the surface area of the Earth. Therefore, the curvature, the routes, they would not have to be different whatsoever. Some flat earthers think there would be a huge dramatic curvature while flying at high altitudes, and you wouldn't see that obviously because the aircraft is not even half of a mile, right? Versus the Earth being 196.9 million square miles, right? So obviously you wouldn't see a huge dramatic curvature while flying in the air. And so that argument is just silly. Now the second argument I'll be addressing today is the argument that many flat earthers say, which is water doesn't curve. And I don't understand the point of this argument. But what they say is right now the water on the Earth is level and therefore it should be flat. And if the Earth was to be curved, the water should be falling off the edges or at least curved a little bit. Now this is just very silly because one of the things is the Earth has a gravitational pull. So naturally, let's say this is the Earth, you have water going straight into the center and it's attracted towards the center of the Earth. So with this argument, the water, since it's being attracted to the center of the Earth, it is most likely going to be flat around the outside because a lot of it's trying to go down towards the center. Now to put this into perspective for us, if you take a look at the Gravitron rides at fairs, the centripetal force of the ride increases as the speed increases. So just because the ride is spinning in circles doesn't mean everything around it or inside it is chaotic. You naturally stick to the outer walls of the ride because of the normal force, which is the force perpendicular to the wall. So this normal force is what makes you feel like you're being pushed against the wall. So the argument that water doesn't curve it doesn't make any sense at all because again the Earth has a gravitational pull towards the center and thus that stabilizes the water on the surface. Now the third argument I'm addressing today is the Bedford level experiment. So in the 19th century, scientists essentially said over a long stretch of water it remains flat, thus the Earth has to be flat. Now this is just a silly argument because obviously from our own perspective we can see that anything is flat. Roads are flat, grass is flat, many different things are flat in front of us, and so that doesn't mean essentially the Earth is also flat. That is just plain wrong. Now the thing is, since we're on a small part of the Earth, we cannot see the whole Earth as a whole, right? We only see a small portion of it. So if we look at a small portion of a rubber ball, for example, you would think it's flat because you only see one side of the surface and you don't see any curvature. Now if you were shrunk down to the size of that ball, it would most definitely look curved. So the same rule applies here. So the water over a long stretch, if you were to shrink down proportionally to that water level, it would most definitely appear curved. But because we are much bigger than that water, it does not appear curved. And this is just a silly argument. Now the fourth argument I am addressing today is many flat earthers think that NASA and the government are creating these fake space expeditions just to fool all of humanity. And my response to that is, why in the world would they do that? What do they gain out of that, really? There's no gain out of it. There's nothing really that they really actually profit from as part of the space expeditions. And there's many different researchers in the field, and I don't know why they would fake any of that for just any reason at all. And there wouldn't be that many, you know, physicists, there wouldn't be that many astronomers in the world if all this stuff was fake. The fifth argument I'm going to be addressing today is the lack of natural curvature. And what flat earthers mean by this is they cannot see the curvature of the earth. And according to the calculation, they say the curvature of the earth should be able, you know, we should be able to see it over long distances. Now, this is just, you know, you can't really put this into perspective with anything, because the thing is, when we compare ourselves to the surface area of the earth, we are very, very small. And so, you know, comparing ourselves and, you know, trying to find the curvature of the earth over long distances is just, you know, you would really have to focus very hard for that. And you would have to fly, you know, somewhat low level to the ground and, you know, take a taller building as perspective and see if it starts disappearing over the horizon. And that's really the only way to really see, you know, the natural curvature of the earth. But other than that, there's no other way that we can see it. Now, the sixth and final argument I'm going to be addressing today are gyroscopes and what they're used for in planes. Now, some flat earthers, they argue that, you know, gyroscopes and everything, they provide no, you know, real use in the plane, and that most of them, they don't even account for the curvature of the earth. Now, I don't think many flat earthers know what a gyroscope is, but a gyroscope is used for, you know, measuring angular velocity, right? So the tool that's used for measuring angular velocity, when you're going over an angle, you know, it can find the velocity of that, and essentially the curve of the earth is at an angle. So I don't know what else to say. I mean, that's what a gyroscope is used for. So these are the arguments I'm presenting to you guys today. Let me know what you guys think down below in the comment section. Do you guys agree with these? Do you guys have any other arguments you want me to address? Let me know. And if you guys enjoyed this video, make sure you guys like, subscribe, and hit the bell button down below. And before I close this out, make sure you guys share this video with your friends that think the earth is flat. Alright, go tell them that, hey, they're wrong, and provide them all these arguments. And I'll see you guys in the next one.